Let's take a look at our problem of the day. Problem of the day says the measure in degrees of an obtuse angle is represented by 5x minus 20. What is the range of values for x? All right, let's look at this one and let's think about it. First of all, we've got some important words here, and everybody needs to know what obtuse means. Everybody says, oh, it's greater than 90 degrees. Well, that's partly true. It's partly true. What else it is less than 180, because once it becomes 180, we go to straight angle status, and beyond that, well, we just don't have angles. We've got degrees, and we do things with those, but it becomes beyond our definition of what an angle is. So we're going to look at the obtuse angle basically being between 90 and 180. Doesn't get there because 90 makes a right angle and 180 makes a straight angle. So you're somewhere in between. So inevitably, that's why we have the word range of just the word range and of values, a whole little phrase expression there. There's more than one answer. In fact, there are many, 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 many answers. All right, count them. How many? We're going to find out. We're going to check it out. And by the way, the answer does not have to be an integer all the time either. There are a lot of values for x that are not going to be integers. So start thinking it's going to be an inequality type situation. So let's take a look. First of all, we have said that 5x minus 20 is going to be greater than 90 because we want that to be a larger value than 90 degrees. So that's the first situation. Also, and I'm going to put a big and here because it's got to work both ways. We also want that 5x minus 20 to be less than 180 up there. Notice I didn't put 179. I did not put 91 here. It could be 90.5. It could be 90.25. It could be 90.000001 and still be in that obtuse plan. All right. Up here, the same story. Doesn't have to be one. It could be 179.5. Your old 0.5 there. How about 3/4, 4/5? Get closer and closer to 180, but it's still lots of ways to go. So you say, well, Ernie, how are we going to accommodate for all of these possibilities? We're going to solve them first, just like you did back in the old days of, pre-algebra and algebra 1. Let's work on the inequality part first. We're going to add 20 to both sides. And already some of you are going like, oh, I get it. Good. I hope you do, and I hope we'll have it right here in just a second. We have, it looks like to me, the 20s are going away. We got 5x left over, which is nice because 5 will divide into anything and give us at least a decimal. Only this time we've got zeros on the end over here, so I've got 110, which is really good because 5 divides in that evenly. It'll go, divide both sides. By the way, we say the properties of equality a lot. This one is the property of inequality. If we add the same thing to both sides, the inequality hangs out the same way it has been. So that's what's happening here. It's the addition property of inequality. Now we're going to divide both sides by 5, and as long as it's a positive 5, we're not going to worry too much about anything. No signs are going to shift here. It's going to be pretty straightforward. And in looking at that, how about it? 22. But notice it says greater than 22. That accommodates for the fact that if it hit 22 on the money, we would be at 90 degrees. We can't do that. So it's going to be a greater than situation to start with. Now remember I said got to cap off. Got to cap off the top. So let's take a look at the top side of this thing. We're going to add again. Hey, 20 to both sides. Why not? And same old thing. The addition property of inequality. So we're going to add 20 to both sides. It does not affect the inequality when we add or subtract numbers, by the way, from both sides. It still keeps it, if it started less than, it's still less than. If it was greater than, it's greater than. So in this case, we are down to losing the 20s once again. But over here, we've got a little bit different. We got 5x. And this time, the number that is coming out looks like 200. 200. And we're going to do the same thing. I'll just do the division moment here. Division property, inequality. You got it. And we're going to go x less than 40. And that's our other situation. Now, there's one word here that's very important. That's and. This and. What do we do with this and? I keep repeating that word and, but it's important. because both of these have to hold true at the same time. So x has to be greater than 22 and also less than 40. So what that does to me, or what that does in my mind, is says on the number line, we're going to find those two values, 22, and we're also going to find at 40. And remember, we don't want to include those because that would make 40 would make a straight angle happen here. If I'd say 5 times 40 minus 20, I'm at exactly 180. I don't want that. I want to get close, real close, but not that close. We don't want to hit 40. So we're going to leave an open circle there. We already decided 22 is going to give us 90 if we hit it on the money. So again, open circle here. Now the question is, what about all those other values I talked about? You know, there's going to be a lot of decimals, a lot of fractions, mixed numbers, all sorts of good things there, depending on how you write your final situations there. Is it between 22 and 40, or is it on the other sides of 22 and 40? That's the big question mark. So let's talk just real quickly about it. Since it's an and, usually we're thinking of where they overlap. And I'm talking about, first of all, if I'm looking at greater than 20, I'm going to the right of 22. On here, I'm going to the left of 40. And I'm looking for where do they overlap? Well, they overlap. Nice stuff here in the middle. And we're just going to shade out in there. Any value between 22 and 40, not including 22 and 40, makes it happen here. So you could check it, pick one of those values. How about it? Let's go with maybe 30. If I put a 30 here, I've got 5 times 30 minus 20. Goodness, that's going to be 130, I believe. 30 is an easy number to substitute in case you are wondering. That's definitely greater than 90, so that's a good value. Does it work on the other one here? Does it still say less than 180? Well, we just figured out it gives us 130, and 130 is definitely less than 180. So that plus any other value that you test between 22 all the way up to 40, not including those, get real close. They're going to fit that, and there's your solution. Wow. So, oh, by the way, one more quick note. How about it? We would write that as a combined inequality. 22 is going to be less than x, which means x is greater than 22. And then this part was really easy. And that really describes what we have on our graph. So there's your story. Combined inequality, obtuse angles, little algebra and geometry fused together. Yep, it happens out there. And it happened today on Mathline. So there we have our problem of the day.